let's try another example.
Okay.
So let's say we have 250 milliliters of a 0.25 molar solution of NaCl. Now let's figure out how many grams of Cl do we have?
Well, the same thing with the top, you would find the amount of grams for the NaCl, the
Right.
moles.
Mm-hmm.
So you just multiply 0.25 times whatever that is added up. Wait.
So this one's tricky. Let's go through this one because I don't know if you've hit these problems yet. But this right here is like a big red flag for us.
Mm-hmm.
This means that it's no longer a straight conversion of this. Because if we're just given, if we just say that we have a 0.25 molar solution of NaCl,
Mm-hmm.
then we can assume that this is 1 liter. And we can say that this has 0.25 moles of this.
Okay.
Does that make sense?
That makes sense, yeah.
But because we only have 250 milliliters of it, we don't actually have that many moles. Does that make sense?
That's what it is in a liter.
This is what it is in a liter.
Mhm.
This is how
That's
much
how
we
much
have.
you actually have.
Right.
Right.
And
okay.
so what we do is, because molarity is equal to the moles over the liters, what we do is, this is how many liters we have. So we convert this to liters, and we have the molarity. So we would just do 0.25 is equal to 0.25, and then this is our moles. And we can multiply these together, and we find out how many moles we have. Does that make sense?
That does make sense.
And so whenever we're given an actual amount of solution, we need to pay attention to this, because this really determines how much of this substance we have.
Okay.
But in the first problem, it just said that we had this molar solution. So we can assume that we have that many moles, right?
Okay.
Cool. So I'll let you take it from there.
So I got 233.76 after,
273.6 grams.
well, all I did was I added up the
So-
value of Na and Cl together and then divided by 0.25. I don't know if that's
Okay.
right.
Yeah, so let's work through this one. First, we need to figure out how many moles we have. And so we can find how many moles we have by multiplying these two numbers together. So what's 0.25 times 0.25?
It's 0.0625.
0.0625. So this is how many moles of NaCl that we have. Okay, and that's just because we multiplied this over here, and that just left moles by itself. Because we're still just looking at this equation for molarity. Because we're given the molarity, we're given the liters, and then we can find the moles that way.
Okay.
Okay, so this is how many moles we have. And then the process that we did before, we did 1 down here at the bottom, right? 1 mole is equal to 22.99 plus 35.45, right?
Mhm.
That gives us how many grams there are, right?
Mhm.
Oh, well, before this, we'd want to do our stoichiometric conversion, right? So if we're looking for how many moles of chlorine there are, we want to look and see for every molecule of sodium chloride, how many molecules or how many atoms of, how many parts are there of chlorine. Does that make sense?
That makes sense.
Okay, so we have this many moles of this, and then we look at the ratio, there's just a 1 in front of this, right?
Mhm.
And there's 1 sodium to 1 chlorine. So we can just say that it's a 1-to-1 ratio.
Okay,
Does that make sense?
that does.
So for every 1 mole of NaCl, we have 1 mole of chlorine Cl.
Okay.
And so after this, then we would put in, because we're looking for chlorine, right?
Right.
And so we use this conversion factor to get moles of chlorine, and then we would just do 35.45 grams. Over 1 mole of Cl.
So that's 2.21.
2.21 grams
Mhm.
of Cl.
Mhm.
Any questions about how this happened?
No, I just need to study it.
Yeah, is it coming back to you?
It's coming back, yeah. Man, that was a while ago, so.
Yeah.